Okay, fine. Yes, I know. 3D collisions in GameMaker Studio 2. I've put this off for like a month and a half, and I'm finally gonna start making videos on it. Okay, hello all you crazy people out there. My name is Michael the Wizard Dragon, and welcome to 3D collisions in GameMaker Studio 2. People have been asking me for this for a long time. I've been procrastinating it for a long time, but here we finally are. So I'm going to do a bit of a long introduction to this before I actually get into code. If you don't care about any of that and you just want to see the code, go to whatever the time on the screen right now says. Otherwise, there's some stuff that bears mentioning first. So, GameMaker, as you probably know if you've been asking for this, does not have a built-in system for 3D collisions. It has a very good system, a built-in system for 2D collisions, and in some situations, depending on your design constraints, you can use that for 3D. Most of the time when people ask for 3D collisions, that's not what they're talking about. That's not what I'm going to be talking about in this video. Leveraging the built-in 2D system to work with 3D is something that you can do, but in almost all cases, if you want any degree of granularity, that's not really going to work super well, which leaves a couple options. One is that you can try and implement your own 3D collision system in native GML, and that is something that I am not going to be doing here, although a couple people have expressed interest. So I'm probably going to try and put something functional together for that in the future at least. If you don't want to do that, and if you don't, I can't say I blame you, you're going to want to find a system that somebody else has already made. And there are a couple answers out there. One you may have heard of is P3DC, Precise 3D Collisions, which is a 3D collision system for GameMaker, I believe GameMaker 7, which goes back about, I want to say 11 years now. And a long time ago, I made some videos on that, and the system does indeed still work in GameMaker Studio 2. You can use it. It's an external DLL. If you don't already know about those, I'll explain the implications of that in a minute. Unfortunately, I would not recommend using it. For one, it's very limited in what it does. You can do triangle-triangle intersection, you can do model-model intersection, you can do raycasts against various things. After that, it starts to become a mess. For another thing, it's very, very slow. What it does in a nutshell is it checks every single triangle to see if it's intersecting with every single other triangle, and if you think that is not going to scale well in a world with a lot of objects in it, you would be correct.
Hey.
For simple purposes, it's good enough, but I can't honestly recommend using it for anything more than a small project. Another solution that you may have heard of is, if I can drag a browser tab onto this window, this thing called SMF. And SMF is a system used for, let's see if I can find the GameMaker thread. Here we go. SMF is essentially an entire 3D game making system for GameMaker Studio. It's tempting to say it's plug and play, but it really isn't because you do actually have to do a lot of work to get it working. It's just work in different areas than what I've been dealing with in this tutorial series. But one of the things it does contain, in addition to skeletal animation and inverse kinematics, because the heavy metal Viking dentist Sindar Larsen is just insane, is 3D collisions. If you're interested in some of these other things, this may be worth having a look at. I do want to make videos on this whole thing at some point in the future because it's fascinating, but unfortunately I've got enough on my plate right now as it is. I will have a link to it in the video description. The solution that I'm going to be going with in this video right now is another 3D collision system, which is the not very helpfully named 3D collision detection DLL. So this is a wrapper for something called Bullet. Bullet is a open source 3D collision / physics system. It wasn't written for GameMaker. It was written for just general purpose game development. You can use it in other things. If you were to make your own game engine, you might want to have a look at it. It's free and open source. If you're using libgdx and you've used 3D collisions in libgdx, you have used it. It's been used in some other things. But a couple years ago, this user on the old GameMaker forums called Venomous has created a wrapper DLL for it to make it work in GameMaker Studio, and it's very good. However, because it is a DLL instead of native GML, that does mean a few things. Namely, it means that this is only going to work on Windows platforms. If you want to work on your game for Mac or Linux or some kind of mobile device, it's not going to work. DLLs are compiled code for Windows only. Another problem here is that you can see I am viewing this thread on the Wayback Machine, the Internet Archive. For those of you who don't know, the Wayback Machine is just, it periodically snapshots pages on the internet and archives them. This thread no longer exists. The old GameMaker forums no longer exist. They have been replaced by the new GameMaker forums several years ago now. If you try to scroll down and look at the download, this doesn't go anywhere. The download has not been archived, and I believe even before the old forums were taken down, whoever was hosting the files decided to remove them. So that makes accessing the files a little bit of a challenge. Fortunately, I have the files and I will be rehosting them. Part of the reason that I didn't make this video years ago was because I didn't feel great about doing that, but at the end of the day, this is a really good system and I don't want it to be lost to time. I have not been able to find anything about the user who made it. I have not been able to find out anything about Venomous after the old GameMaker forums were shuttered. I would have liked to have been able to get in contact with him, her, whoever, and ask some questions about the inner workings of it, but I have not been able to do that. If Venomous or anybody who knows Venomous is watching this video, definitely let me know, and I will try to get in contact again. So with all that said, how to get the files? If you go into the video description, I will have a link to a GitHub page for this project, and if you go to the releases tab on that GitHub page, there's going to be one release, and it's going to contain a YYMP file, which is a GameMaker archive. If you download that, and then go into your project, go to Tools at the top of the menu bar, at the top of the screen, Import Local Package, and if you go to wherever you downloaded it to, venomous.yyMP, select that. It will ask you what you want to import into your project. There are a collection of scripts, which you can add, and there are a collection of included files, which you can add. I would just say add all, import them into your current project, and we can be on our way. So collisions_example.gmz, the included file, this is non-critical. This is the original demo project that was that Venomous made to go with the DLL. I personally find it useful if you want to extract it, import it, and mess around. This was for GameMaker Studio 1, but you can... this was for GameMaker Studio 1, but you can import it into 2 and it will still work with minimal changes. You can mess with it if you want. I'm just going to delete it from this project so that it's not sitting there taking up space. The other files that were imported is collisions.dll, which is also an included file, and a collection of scripts called Venomous Bullet Collision. And there's a bunch of them. You can look through them to see a preview of what's to come. I'm going to be talking about most, if not all, of those things in due time. So to get started, go to wherever your 3D-ness is initialized. And for me, that's the camera. For you, it may be a world or a game manager or something object. This project is probably getting to the point where I should separate stuff out and organize it a little bit better, but I've already put off making this video for long enough, and I don't want to put it off even further. C_init is what we're going to start off with. And all this is going to do is initialize the DLL. As you can see, in GameMaker, for those of you who don't know, DLLs, dynamically linked libraries, are, as I said before, compiled binary files that, instead of launching a program, contain code that can be referenced by other programs. For us, that means the DLL contains a bunch of functions related to 3D collisions, and here is where we initialize them with the external define function. If this all looks like mumbo jumbo to you, that's okay, don't worry about it. We don't need to touch it. The second thing that we need to do is C_world create. And this is going to initialize a collision world. And this is exactly what it sounds like. Worlds are the space which collision objects exist in and where collisions can happen. For the most part, you just need to create a collision world at the beginning, and you're good from there. If you want to, you can see world destroy if you want to reset the collision world. See world exists is something that you can check if you want to see if a collision world is currently existing. The next thing that we need to talk about is the concept of collision shapes and objects. And before I get ahead of myself, if I run the game, this is almost what I was showing off at the beginning. There is no collision information. This is just a collection of red cubes and violet octagons. As you can see at the bottom here, I'm loading in the cube and the octagon. Those are included files, cube.d3d, octagon.d3d, and they are just being drawn in the draw event right here. Now moving on, I'm just going to create a line using slashes so that we can quickly identify the section of code that is collision stuff. Shapes and objects. I've already mentioned a collision world contains collision objects. And the information that determines how collisions are detected is stored in shapes, and each collision object has an associated collision shape. To use another game dev metaphor, you can think of the shapes as the templates and the objects as the instances. The shapes would be the classes, the GameMaker objects, which you see in the resource tree, and the objects would be the instances of those. Oh god, this is confusing. Verbiage. Anyway, the point of all this is that you can have one single collision shape, and multiple objects can be represented by it. So if you have something like a barrel or a rock, instead of duplicating the information for the shapes of those objects, which could potentially be fairly large 3D meshes, you only need that information to be loaded once, and all of the many, many instances of barrels and rocks in the world can just reference it. So now, because code is probably what you're all here for, let's actually start writing code. I'm going to start with, let's start with the cubes. So I can say C shape cube is going to be C shape create. So we're going to be creating a collision shape and storing a reference to it in this variable. And there are a few things that you can do to define a shape. There are a few built-in primitive shapes. You can say C shape add, and then you have boxes, capsules, cones, cylinders, planes, spheres, and triangles are not what we're looking for. That's something else. Boxes, capsules, cones, cylinders, planes, and spheres. And if you've used the old GameMaker D3D functions, or if you've used P3DC, you may be familiar with a couple primitive shapes. Those were different in that all they did is create a triangle mesh in the shape of a box or cylinder or cone or one of those things. They had a limited degree of precision, and if you were to try and detect collisions with one of them, it would boil down to checking every single triangle in the generated mesh to see if there was a collision, which, as I've said before, is slow. These are mathematically defined shapes. I'm considering making a video in the future talking about just those specifically later on, but since I want to not spend forever on this video, I am going to, instead of using one of those shapes, say C shape begin try mesh. After that, we're going to just load a model from a file, and that's going to be C shape load try mesh. The cube is what? Cube.d3d. So we are going to be loading that file. And then at the end, C shape end try mesh. And this always felt a little bit like defining a vertex format to me for some reason. Although instead of saying C shape cube equals C shape end try mesh like you would for a vertex format, you instead pass it to the function as a parameter. C shape cube, and that will take the model information that was loaded from the 3D model file in the form of a triangle mesh and add it to the collision shape. If you want to add triangles manually, you can use the C shape add triangle function that I mentioned quickly a minute ago and then ran away from screaming. You can use this to manually add triangles. So that's it for the collision shape. Next, we need an object. So objects are going to be similar. C object cube. Actually, I'm going to call it C obj cube because I can get away with not spelling the whole word out every time because that's going to just be excessive typing. And this is going to be C object create. And it's going to take a few parameters, one being C shape cube, another being the group, which I'm going to make -1 for now, and another being the mask, which I'm going to make +1 for now. In my opinion, the collision group and the collision mask is where the real fun starts, but I'm not going to talk about that right now. That's a lot of bitwise arithmetic that I don't want to bog this video down with. You use that for filtering collisions, which is real exciting, I think, but again, let's stay focused here. So the next thing you need to do is add the object to the collision world. So we've instantiated an object. It uses information about a shape. You can say C obj. No, that's not what I was. That's not the right thing that I'm supposed to be typing. C world add object, and we can say C obj cube, and that's just going to add the collision object to the collision world. So the collision object has been added to the world, but as of right now, it's just sitting there at the origin. The cube that I'm drawing is the cube that I'm going to be dealing with, rather, is going to be at 400, 200, 0, and the object that I just added, since I haven't moved it anywhere, is going to be sitting there at 0, 0, 0. So we can transform it. We can say C transform position. C obj cube. Nope, not what I wanted. What was it? 400, 200, 0? Okay, 400, 200, 0. These other shapes, these other things that I'm drawing that I want to collide with, I'm going to deal with in a minute, but first I want to just get it working with one. 400, 200, and 0. That doesn't do anything on its own, so to make it take effect, C object apply transform. C object apply transform is analogous to setting the matrix when you're drawing stuff, setting the world matrix. That's analogous to this line, except it's a little bit more similar to the old D3D transform functions. And C transform identity does exactly what matrix build identity does. It resets the transform, so anything that you any transforms you try to do on objects in the future will be they'll be starting from scratch. Okay, so there is now a collision object in the world, and it's at the correct position. However, if I run the game now, what is 400, 200? That's this one, right? The one in the middle. If I run the game now, I can still run through this. And in fact, just to make sure that I'm not like putting it in the wrong position, I can run through all of them. And there is no automatic collision detection, as you can probably imagine. If I were to go to the player, and if I were to go to the player step, and if I were to look down here, there's nothing telling me to stop if I hit something. So it's time to start working on that. The player also needs collision information, so we will do the same. C shape for the player is going to be C shape create. However, instead of doing something similar to what I was doing here, and perhaps loading the player information from the file, if I were to do this, this would not detect collisions with anything. This can be hugely confusing. This comes down to part of how the bullet collision library was designed. So I should mention, the bullet collision library is insanely fast. Compared to P3DC, it will scale much better for worlds with large numbers of objects in it, and there are a couple of reasons for that. One is that it doesn't simply loop through every triangle in the world to see if there's a collision. It internally uses a thing called an octree, which is a structure that you may want to think of as a 3D binary partition. And it uses that so that it only has to check for collisions with things that are nearby the object that you're checking. And the other reason that it's so fast is that it simply will not do a triangle-triangle intersection. I mentioned before that it uses mathematical shapes. Boxes, capsules, cones, etc. And the reason for that is that there are known equations that you can use to check things like spheres and capsules against the collision world that are much faster than just checking every single triangle. Triangle meshes are great for static level geometry. Trees, rocks, buildings, anything that doesn't move, anything like that.
Hey.
I believe there's actually a note about that in one of the documentation comments. But for things that are moving around, like animals or the player or NPCs, you will want to use one of these basic shapes. You can use a capsule, which is the pill shape. I'm just going to use a sphere for now. So the shape that we're going to be adding the sphere to, rather, is going to be shape. And the radius is, I believe the radius of the player is 16. Let me go real quick. Open up the model. Player.d3d. Why did Windows Explorer just completely refresh on me? And the player has a radius of 16. Okay. A capsule would be a more correct approximation of the shape, but I'm just gonna go with a sphere for now. And then, just as before, C object equals C object create. We're going to be taking the shape. The group is going to be -1, and the mask is going to be 1. Again, don't worry about that for right now. Also, and I can't believe I didn't mention this before, just like many other structures in GameMaker, you probably will want to destroy these shapes if you're ever done using them. For example, if the object that they represent has been destroyed, you probably want to put in the destroy event something like C shape destroy, C object destroy. If the object is currently in the collision world, you will want to either say C object, C world remove object, or C world destroy object. C world remove object simply removes the object from the collision world so that it doesn't trigger any collisions later on down the line, and C world destroy object will do the same thing and also destroy it. If you try and destroy an object while it's still in the collision world, or if you try and destroy a shape while it's still in the collision world, the game is liable to crash, and the error message that you get, since it's coming from inside a DLL, is probably not going to be super helpful. So always remember to only destroy objects that are not part of the collision world, and only destroy shapes that are not currently being used by objects in the collision world. Okay. Where was I? So I'm going to go into the step event where movement happens, and this is going to be a lot of movement code, which you have seen before. So instead of just saying x plus equals minus equals the direction that you're moving in, I'm going to create a temporary variable. I'm going to call them dx, dy. That is not intended to look like calculus, but I'm using that to denote like a difference in x position, difference in y position, which, now that I say it like that, that does sound like calculus. So instead of moving immediately when you press a key, we're going to look at potential movement and store it in a variable, and then we're going to do something much like what you would probably do if you were doing collisions in regular 2D GameMaker, except instead of using one of the built-in collision whatever functions, we are going to be checking for C overlap position. And we are going to be checking to see if we can move to a position. The object is going to be C underscore object. The position that we're looking at is going to be x plus dx, and the position that we're looking at on the y-axis, y plus dy. And then we're going to look that there is no overlap in the position that we want to move to, and if there isn't, x plus equals dx, y plus equals dy. Good. Am I missing an argument? I am missing an argument. That is a z position. We are not worried about z right now. We are not moving up or down. Let's just, for the sake of completeness, let's just pass in the z coordinate though. Okay. I am unable to move, and that is because I accidentally deleted an exclamation mark there. I love how every single time I run the game, there's like one typo that just makes the whole thing really awkward. Okay, so I can run through this. I can run through this thing here, and I can run through this purple thing here, but I cannot run through this. However, I'm slightly stuck. If I can't like slide against the wall or anything like that, which is a bit inconvenient. So again, we can go back to our old 2D collision tricks and check each of the directions separately. Oops. First, we can check if there's anything colliding in the x direction, and then we can check if there's anything colliding in the y direction. And this will cause us to slide against the box instead of getting stuck on it. And you could sort of see it here. So this is the age-old corner collision problem. Sean Spalding did a video many years ago where he dissected that problem and explained potential fixes to it.
Hey.
I'm not going to get into that right now. There is also the minor issue where this will, in some situations, not align you perfectly flush against a wall. Like if your dx, for example, is, let's say, 4 units, but there is a wall 3 units away, this will say, hey, no, there's a collision there 4 units away, but it won't let you get any closer. In 2D movement, the solution to this is to like do this in a loop, where you check in increments until you're up against the wall, but that's not really a good solution here. Not so much that collision checking is expensive, because like I said, Bullet does have a number of optimizations that makes checking collisions quite fast. But because if you have free movement here, if you're moving based on sine and cosine of the angle that the camera is, dx and dy are going to be irrational floating point numbers. They're probably going to be something like 1.41, whatever the square root of 2 is. And you can check in as many, as small increments as you want, but you'll never be able to get perfectly aligned with something. There are other solutions to perfect collisions like that. I'm not going to be talking about them here. If you want to look ahead a little bit, look into collision sweeps and collision raycasts, and that will help you get a lot closer. But anyway, as far as Hello World collision detection goes, we are getting there. I'm going to create another collision cube. Let's call that cube 2. Just to tell them apart. These variables aren't used for anything outside of this, but I believe that the other one was at 300, 300. But I do wanna keep them separate because they are separate collision objects. And there is a octagon at 600, 200. So let's create the octagon collision shape. Like that. And let us create an object to represent the octagon and move it to 600 and 600. So this is collision detecting. I have not... Okay, yes, that's supposed to say shape. Again, goofy little typos causing the whole thing to not work when I run the game. So I can now slide across this box. That's pretty nice. That is not correct. Am I loading the shape wrong? Oh, it's 600, 200. Not 600, 600. Ha! I was gonna say, is like, am I spelling a variable name wrong or something? But nope, it's just in the wrong place. So now I can get stuck on the octagon. The collision is less fine than it was on the smooth squares. You can see I slide across the smooth squares when I'm not jamming myself against the corner. But I only do that at certain angles from the octagon, which is another problem with 3D collisions that I'll probably talk about at some point. But there you have it. That took, how long have I been sitting here? I've been sitting here talking to the computer for almost 50 minutes, and I am not looking forward to editing this video. Okay, as I've mentioned, there are a lot of other things I want to talk about with this eventually. There are a lot of other things that you can do with this collision system. Raycasts, sweeps, other shapes. I want to talk about how the other shapes work, because they do have their uses. Masking, I really like masking. User IDs, so that you can attach GameMaker instances to the collision objects and know exactly what you're colliding with. But that's a story for another day. My voice is getting sore. My name is Michael the Wizard Dragon. If you want the code or just the collision DLL and scripts that go with it, they're linked in the video description. What else was I going to say? There's also a separate branch. I made a separate branch for this project, for the base project, without all of the stuff that I've added. If you want to get started from there with just the cubes and the octagons with no collision information. What else is there? I recently made a Patreon for these videos if you want to contribute towards me making them. There's a link to that in the description as well. Otherwise, I'm going to try and make at least 1 or 2 of these videos a week. I talk about both 3D things and other things. That's it. Have fun with doing collisions, and I will see you all later. Speaking of the Patreon, in the way, shout out to Zenith in particular for supporting these videos. If you want your name in the credits and a chance at me hilariously mispronouncing your name out loud, click the link, join the fun. I need to work on my sales pitch.